So this is an overview of pH and how to calculate it and how to put it all together. So first we need to start with water. So water has a pH of 7, and you know that because the H plus or the H3O plus concentration is 1 times 10 to the negative 7. First I want to start with this, water. The concentration of water is 55.6 molar, that's moles per liter, and that actually comes from its density at temperatures above 4 degrees Celsius, so where we are. And what happens is it actually auto-ionizes and forms H3O plus and OH minus in very, 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 very small amounts. So what happens is this hydrogen actually attaches itself to this water on the oxygen, so you get H3O plus and OH minus. And remember, pH actually measures the H plus or H3O plus concentration. So pH is equal to the negative log of the H3O plus concentration. And when we put that in, we get a pH of 7. That's what we see here. Now, let's look at the product of these two. So if I take the H plus concentration and the OH minus concentration, and I multiply them together, so let's see, 1 times 10 to the negative 7 times 1 times 10 to the negative 7, I actually get 1 times 10 to the negative 14. And this is actually a very, very important number because as it turns out, the H plus concentration times the OH minus concentration will always equal 1 times 10 to the negative 14. This is how you can get the relationship from the OH minus concentration to the H pluses. So if you're given the concentration of a base, you can divide 1 times 10 to the negative 14 by OH minus, and you'll get the concentration of the acid, or the acid remaining in the water, and you can get the pH from that. So let's look down at an acid. So notice I've clicked strong acid, and that's very, very important. What happens is HA completely gives all of its protons to water, and we get H3O plus and A minus. And as you can see here, you see all the H3O pluses. We can get the pH calculated by looking at the H3O plus concentration. So pH is always equal to the negative log of the H plus concentration. So pH is equal to the negative log of 1 times 10 to the negative 2. When you put that in your calculator, it's positive 2. Okay? So let's do some quick calculations. So pH is equal to the negative log of 0.01. So we just did that one, so it is 2. pH is equal to the negative log of the 0.001, and that is 3. pH is equal to the negative log of 0.005, and that is 2.3. I'm just putting it in my calculator. And pH is equal to the negative log of 0.045, and that is 1.3. Well, you ask, well, this is the concentration of the entire molecule. How can that just be the H pluses? And that's because, and let's use HCl for example, it completely gives all of its H's to water. So we form H3O plus in the same concentration as the HCl because all of the H's were given to water. So for strong acids, the concentration of the entire acid is actually equal to the concentration of the hydrogen. Well, what about going backwards? If we've got the pH and we want the acid concentration. So let's set that up. pH is equal to 5. So pH is always equal to the negative log of the H pluses. 5 is equal to the negative log of the H pluses. Well, let's see, that's -5 is equal to the log of the H pluses. And now remember, this is log base 10. So remember the sentence is log means the power to which 10 must be raised to get the H plus or H3O plus concentration is -5. Or you take the anti-log of both sides. Depends on how your teacher taught you. So negative 10 to the -5 is equal to your H plus concentration. And go ahead and put a 1 times 10 to the -5 and put a molar behind it. Let's do another one. pH is 2.5. Well, we know that the H3O plus concentration will be equal to 10 to the negative pH. That's what we just saw happen. So H3O plus is equal to 10 to the negative 2.5. You cannot leave it like that. You cannot just put a 1 like I did up top. You have to put that in your calculator, and when you do, you get that the concentration is 0.032 molar, and that is the H3O plus concentration. Remember, H3O plus and H plus are the exact same thing. Let's look at bases. So bases are the things, the OH minuses. You can see them here in equal parts, M and OH. And yet we still have a pH. Where pH, it has to do with the H plus concentration. So what has happened is the OH has kind of displaced the H's in this relationship. And really, it's not displaced, it's the OH's went up, so the H pluses had to go down because they're always going to multiply to equal 1 times 10 to the negative 14. So let's see that in action. So if our OH minus concentration is 1 times 10 to the negative 2, let's write that relationship. H plus times OH minus will give you 1 times 10 to the negative 14 always. So the H plus concentration has changed because the OH minus concentration increased to 1 times 10 to the negative 2. 1 times 10 to the negative 14. So they multiply together to still equal that, which means the H plus concentration is now 1 times 10 to the negative 12 molar. I'll put that in the pH equation, negative log of the H pluses. So the pH is equal to the negative log of 1 times 10 to the negative 12. So the pH is equal to 12. That's how we get that. We had to take 2 steps to get to pH when we have a base, but that's how we do it. There's also something very interesting that happens with this equation. If you know your properties of logs, you know that I can take the negative log of both sides and get something like this. Negative log of H pluses plus the negative log of OH minuses equals, if I take the negative log of 1 times 10 to the negative 14, I get 14. Well, negative log has a quick abbreviation, right? P. pH plus POH equals 14. So we get this quick relationship, but we really need to define this. POH is equal to the negative log of the OH minuses. This is another interesting piece. POH is usually never the answer. Unless the question specifically looks for it, don't calculate POH. You're always trying to get to pH, but this is a quick way of getting there. So we have this equation that we can use for bases, we have this relationship we can use for bases, and we have this we can use for bases. So a lot of different ways to get there, and we'll go over exactly what to use when. This is always true, and we just did something very similar to this one. Well, we also just learned that POH is the negative log of the OH minus concentration, and that pH plus POH is 14. So let's do one of these. So POH is equal to the negative log of 7 times 10 to the negative 3. So the POH is equal to having a sig figs problem, but 2.2. And when I want the pH, I say, well, okay, pH plus POH, which is 2.2, is equal to 14. So that means the pH is going to be 11.8. That's one way of doing it. You could have gotten the concentration of the H pluses from this and then gotten the pH. Both ways work. Well, what if we're given the pH and we need to find the concentration of the OH minuses? We need to convert this, if you want, to POH, or we could convert it to the H plus concentration. Either way, we can get to the OH minus concentration. This is a strong base, so the OH minus concentration does equal the entire concentration. Students usually prefer this method, so we'll go through the POH. So pH plus POH is 14. 7.5 plus the POH is equal to 14. So the POH is going to be 6.5. Okay, well, I've got the POH. How do I get the OH minus concentration? Well, I know that 6.5 is equal to the negative log of the OH minuses, which really means 10 to the negative 6.5 is equal to the OH minus concentration. Well, let's put that in our calculator. When I put that in the calculator, I get 3.16 times 10 to the negative 7 molar is equal to the OH minus concentration, which is actually equal to the KOH concentration. These brackets are important. They do mean concentration. So, how to get from where, what, when, and fully navigate. This is called the pH square. And if you are given pH and you need to go to the OH minus concentration, you have two ways to get there. You can follow this path across and then up, or you can go up, then across. If you have the POH and you want the pH, you just simply go across. If you have the H plus concentration and you want the pH, you go down. And notice we've got the equations written right here that you can use. All roads lead to the correct answer. You get to choose which path. So let's do a few examples. So it says, calculate the pH of the following when you have H plus equal to this concentration. Well, I'm trying to calculate the pH. I've got the H plus concentration, so that's a one step. You probably knew that. So I know that pH is equal to the negative log of the H plus concentration, that's H3O plus as well. pH is equal to the negative log of 1 times 10 to the negative 5. And I do need to see work. pH is equal to 5. So getting pH from an acid is one step. So that means that's the same thing for number 2. Let's skip down. Let's look at this one. This one looks interesting. We're actually given the POH. We're usually not. So this is what we're given. And then we need to calculate the OH minus and the H plus concentration. So there's a one step and a two step. So from POH up to OH minus, we're going to say OH minus is equal to 10 to the negative. I'm going to go ahead and insert the POH. This is the antilog. You need to use your calculator. OH minus is equal to 2.34 times 10 to the negative 12. Don't worry too much about sig figs on this one. Generally go with 3 in your answer. Now, I'm already up here. I can go one more step by just using this equation right here. Unfortunately, a lot of people are like, oh, well, I need to go another route and go the long way. You don't have to. One more step. So, you know the H pluses times the OH minuses are equal to 1 times 10 to the negative 14. Well, you're looking for the H pluses. You've got the OH minuses, so 2.34 times 10 to the negative 12. That is equal to 1.10, this number here, 1 times 10 to the negative 14. And when I do the math, I get an H plus concentration equal to 0.00427, just sticking to that 3 sig figs. Now this is interesting because if you look back here, that's the pOH. So what does that mean about the pH? It means that the pH is equal to 2.37. So this is an acid. Even though we asked a lot of information about the base, this is actually an acid. Okay. Number 4. We've got a concentration of OHs, and we need to get to pH. Unfortunately, there's no road across. We have to go around. So we could go down and this way, or we could go over and then down. Either way works. So I say we go down then over. So that means we're going to say that pOH is equal to the negative log of the OH minus concentration. So pOH is equal to the negative log of 4.6 times 10 to the negative 6. So pOH is equal to 5.34. Well, no one ever wants pOH really, so we need pH. So pH plus pOH is equal to 14. pH plus 5.34 is equal to 14. Therefore, the pH is equal to 8.66. So it's basic. Okay, this is the same one, starting here, going down here. Let's go this way this time. So we know that the H plus concentration times the OH minus concentration always will equal 1 times 10 to the negative 14. That's a property of water. The H plus concentration times 0.54 is equal to 1 times 10 to the negative 14. Therefore, the H plus concentration is 1.85 times 10 to the negative 14. It's pretty impressive. So pH is equal to the negative log of the H plus concentration. So pH is equal to the negative log of 1.85 times 10 to the negative 14. So this is a pH equal to 13.7. Notice 2 steps. Anytime you're dealing with a base, you've got 2 steps. Okay, so pH from an H plus concentration, that's just using this one, right? Okay, so we want the H plus and the OH from a pH. So that's going from here to here and also to here. So I would go up first and then over. Okay, we've seen this one. So even though we've seen all of them, let's do one more that's kind of hard. This number 9. So we're going to calculate the OH minus from the pH. Remember, we can go up and over, across, and up. So let's do some calculations. I think going across and up is a little bit more fun. So I'm going to say that pH plus pOH is equal to 14. The pH is 7.51. The pOH is what we're calculating, and that equals 14. So the pOH is equal to 6.49. So we've gone across, we've used this equation. So now we're ready to turn upwards, and so we're going to use that equation. The OH minus concentration is equal to 10 to the negative pOH. OH minus concentration is equal to 10 to the negative 6.49. That means the OH minus concentration is 3.24 times 10 to the negative 7, got to put a unit, molar. Notice that pH and pOH do not have units, but all concentrations do.